over the for this question. They gave you 3 points and you had to figure out which point those are. Now there was something a little bit confusing about this question in the sense that they gave you the 2x intercept, but they also gave you the y, right? You guys notice that this point 0, 12 is actually also the y-intercept. Now, yesterday we wrote in that note that if they've given you the y-intercept, put that into the standard form, right? But guys, if they've given you the x-intercept and the y-intercept, it's better to work with x-intercept form because you can put in 2 things, right? If you have to work with x. Whereas if you're just putting in the y-intercept, you would just get y equals ax squared plus bx plus 12. And then where do you go from there? All right, so now you have 2 variables left. Which is a bit more difficult. Okay, so I would suggest if they have given you the x, regardless of what else is given, use the x. Okay, so that's what I did here. We remember that x brackets always have different signs in the brackets or in the coordinates rather to what you have in the actual bracket. So because it's negative 4 here, you're going to have x plus 4. And because it's positive 1, you're going to have x minus 1. And then in order to calculate a, you need to start in the other point, which is 0, 12. So 0 is the x value and 12 is the y value. I just wrote mine now the other way around because I like having my a on the side. But it's fine if you put your 12 equals and then you start with so you would calculate this. It's a nice easy one. That's 5, 4 times negative 1 is negative 4. And then a, and that's equal to 12. So then you say 12 divided by negative 4. Okay, you will probably get, I think I did say yesterday, it's like a 4-mark question for this, 1 mark for subbing in the x-intercept, 1 mark for showing that substitution of that point. Sorry, I don't know why this is. And then 1 mark for your a value, and then 1 mark for your answer. Okay, were there any questions on that first? The next one was a bit more difficult because you now had a fraction, right, as your 1 x-intercept. Guys, you do the exact same thing. These two are both x-intercepts. Again, how do you recognize that these 2 points are x-intercepts? The y value. Good. The y values are both 0. Okay, so we see that and we recognize these are x-intercepts. And then they've given us a third point that we're going to have to just sub in. So that x-intercept is positive 3 over 2, so you say x minus 3 over 2. That one is negative 4, so you say x plus 4, and then you get 1 mark already. Then whatever your other point is, you're going to substitute in. X is now going to be 2, and y is going to be negative 3, so there you put your 2 x's. So your x value, which is 2, and that x value, which is 2, and there is your y value, 3. This you didn't, I didn't have a calculator with me, so I just did this in my head. You didn't have to write this next line. You can just type that into the calculator and go straight to 3a, right? But I just did it separately. So 3a was equal to negative 3. Then you divide that by 3, you get your answer. Now guys, here, in your final answer, it is okay if you wrote negative 1 there. We just don't usually write the 1, unfortunately. Questions on that? Okay, 2.2. They gave you the turning point, so now you need to use turning point 4. I wrote it out there. Again, the x value and the brackets in the actual equation have different signs. So positive 1, so you're going to have x minus 1 squared, and then the y value is 2. Then you sub in the other point that they gave you, 2, 1. So x is going to be 2 and y is going to be 1. So there's my x equals 2. Sub in there, and your y equals 1. Yeah, again, this bracket just becomes 1, right? 2 minus 1 is 1 squared, which is 1. So that's just a minus 2 equals 1. And then this negative 2, we just need to add on the other side. 3. And then you go on. This one, same mark allocation, 1 mark for summing in the turning point, 1 mark for summing in that other point, a mark for the value of A, and then a mark for the A. So always 4 marks. Any questions on parabola? Alright, then you had to do 2 hyperbola questions. So I just wrote down what was given. They gave us the 2 asymptotes, x equals -1 and y equals 4 for the first one. So again, guys, okay, firstly, it's a hyperbola, so that's the standard form. The sign is always different for x. So because it's -1, you have to put x plus 1. And the y one always keeps the sign. So it's +4, so we put +4. Again, guys, that will give you 1 mark. Possibly 2, right? Maybe 1 for some. Then you need to take the other points they gave you, which is 1, 3. I didn't write it there at the top, but they gave you that point. So now your x value is 1. So that x becomes 1. And your y value is 3. So it's equal to 3. And then you need to solve for a. So I just simplified this quickly. That at the bottom is 2. And the 4 goes to that side, you can put 3 minus 4, that's where that comes from. And then you must times that. So a will be. As it is okay if you wrote it like this, if you put the -2 at the top. Okay, that's all right. It's just, I think, great to put the minus in front, but it's okay. And then, I don't know if you guys remember, they asked for the axis of symmetry, which unfortunately, if you got the equation wrong, this also would have been wrong. But remember, for the axis of symmetry, it's always, you always gonna have 2. So for the first one, you take your denominator and your q value, just exactly as they are. X plus 1 and then plus 4, and you simplify. So that's the first one. For the second one, which is the -1, you're going to take negative denominator and then again plus 4. Then you have to multiply that -1 again and then simplify it. So guys, I just want you to write down, this is the one with the positive gradient, right? Because your m value is always positive, just 1, positive 1. Alright? Because in the homework that you're going to do later on today, we're going to talk about the axis of symmetry with a positive gradient. Then you need to know they're talking about this one. Or the axis of symmetry with a negative gradient. Then you need to know that they're talking about the one with a minus in front of the denominator. Alright, the gradient of this line is negative. So just add that in. Let me know if you have any questions on that one. There was another one that you have to do. 3. Look at that one. I know regarding the first bit, again, they gave you the 2 asymptotes. So because that one is -3, we have to write x plus 3, and the y one, we get the sign, so it's -2a. Then the other point that they gave you for this one was -1, -4, so you have to start that in. So x plus 3 becomes -1 plus 3. And then the y value is going to become -4. This -2 is going to become +2. This, when you simplify it, is just over 2. And then you just multiply -2 by 2 to get your A value. Again, guys, when it's a negative A value, you can just write it at the top. So you can say this was -4 over x plus 3 minus 2. Alright, axis of symmetry, same thing guys, denominator and your Q value, that will be the one of the positive gradient. So we can just add the again in greater than 0. Guys, if they're asking specifically, right, in the question, find the axis of symmetry with a positive gradient. You're just going to do this one. Alright, then you're not going to do both. If they're saying find the axis of symmetry with a negative gradient, you have to do the one with it minus its positive. Okay, sometimes they specify. Sometimes they ask you to find like a point of intersection of a graph and one of the two axes of symmetry. Then you need to know which one it is. Okay, but they'll always say the one with the positive gradient or the one with the negative. Just leave that up for a second so you guys can finish copying that down, and then we are going to do an exponential graph example. And then you're going to do some practice. Any questions on that? Okay, now for the exponential graph, I've just done the same heading. So finding the equation of the graph and now you wrote continuous there because it is a continuation of the same note. I'll zoom in now so that you can see this here. Just in a second. We started that heading, guys, finding the equation of the graph continued. Okay, let me just zoom into the actual graph. Sorry, you guys are going to have to draw this graph. I just want to make that -8 to the figure there at the bottom. And then this one here is a -1. So guys, I have done them in two different colors because we have two different asymptotes here. Okay, so just so that you know that the blue asymptote goes with the graph and the green asymptote with the green graph. But you don't have to use different colors if you don't want to. Just moving it down a bit so that you can see that first question. We're going to just basically find the equation of the two graphs. But guys, in this example, the instruction is a bit different. So we do have to just do questions where they So guys, X is the green graph. I would like you just to either highlight or just underline that equation that they've given me there. Just as a reminder that we're going to have to try and look at the green graph. Guys, unfortunately, they don't usually give you graphs like one by one. Okay, they often give you more than one graph on the same set of axes. So you do have to kind of try and ignore the blue stuff. Okay, because that doesn't have anything to do with the green graph. In this case, and obviously in case of exams, they're not color coded. Right, you don't get color paper. So yeah, it's going to take some practice just to get used to that. But they are wanting us to essentially find the equation of x. Because they're saying here f of x, which is the green graph, is equal to ab to the power of x plus c. Now guys, you see that this equation that they've given you is different from the standard form that we learned, right? What did we learn for the standard form of an exponential graph? We said that y is a times b to the x minus p plus q. But now they're using different methods. Right, firstly, there's no p value here in this equation that they've given us. So that means that's actually nice. We don't have to solve for p. Okay, one less variable to worry about. But instead of q, they have used c. Guys, that doesn't change what it actually represents in the equation, right? What was q again in the equation of an exponential graph? It was the asymptote. Okay, so q was the asymptote. So now guys, the asymptote, the q value has been replaced by c. But that doesn't change what c represents. This is going to be the horizontal asymptote. That is now going to be y equals c instead of y equals c. We're not always going to use the letters that we are using. Alright, so you do have to understand it's not always q, it's actually the constant, the one that's just a number that gives you the asymptote. Okay, so can we look at the graph? What is the green asymptote value here? -1. So that means that for this question, C is going to be equal to -1. If you want to, you can put there in brackets the horizontal asymptote. That's how we know that. Now guys, the question is also worded different from what we did yesterday. Yesterday we just said find the equation of the graph. Now they're saying determine the values of A and C. Right? But it's kind of the same thing because if we have the equation of the graph, then we're going to know what A is. Okay. C we can find easily. And guys, that's one mark. Right? There we go. There you have a mark already for getting that C is -1. Just for recognizing that your asymptote is the C value. Now let's look at what else they've given us here. We have 2 points. You see that they haven't given us the x-intercept, right? We can see that it has an x-intercept, but they didn't tell us what that point is. But that's okay. We have 2 variables still to find, right? A and B, we've already found C. And they've given us 2 points, which is perfect. All right, we're going to use one point to find the value of one variable, and the other point to find the value of the other variable. Now guys, for exponential graph, what you always have to do, we're going to write this down, is take or use or sub in the y-intercept first. Okay, so you have to write that down. In B, sub in y-intercept first. Highlight that, draw a bubble around it, underline it. Very, very important. I'm going to show you why. Before we do that, let's just rewrite this equation because we've already found C, right? So let's rewrite the equation with the C value actually written in. Do we remember that f of x is the same as y? Okay, so we're going to write it as y equals. We're going to have a and then b to the power of x and now -1. But if we keep writing c, it's going to look like you must still find c, but you've actually already found. Okay, so as soon as you find that c value, rewrite your equation with that value in. Now the y-intercept that they gave us is pretty y-intercept. They only wrote the actual y value, guys. They just wrote 2. What is that? Is this the coordinates of the graph? Or of that point graph, sorry. What are the coordinates of this point? We know that the y-intercept is 2. It's going to be 0. Good. So that is what we need to sub in. 0 and 2. On the sub in 2. Okay, you have to have an x value and a y value. Now, what happens here? I'm just going to write it again with this side on the left because I'm going to have to solve for either A or B here. We have A, and then we have B to the power of X. But what is my X value now? 0. You guys see what's going to happen there? What's B to the 0? 1. Okay, and then minus 1 is equal to Y. What is the Y value at this point? 2. Now guys, this is why we sub the y-intercept in first, right? Because the y-intercept will always have an x value of 0, which means that if you have a variable to the power of 0, so b or whatever letter they use here to the power of 0, it's almost like we're canceling it out. Because you guys told me now, right, that this is 1. So actually what I have here is a times 1 minus 1 equal to 2. How many variables do I have now? Just 1, right? By putting b to the power of 0, I have actually gotten rid of 1 of the 2 variables that I had. So now we can just say a times 1 obviously is just a. So that is going to be equal to 2, and then this minus 1, when I move it, is going to become plus 1. So 2 plus 1 is 3. But guys, if you sub the other point in first, this won't happen. Because let's quickly look at what was the other point. 1, 5. What's going to happen if you sub that point in first? I'm just going to write it on the side here. If you subbed in 1, 5, you would say, okay, we're looking at this equation, right? We would say a b to the 1, because the x value of this point is now 1, minus 1 equal to y, which is 5. Now you stop because now you have 2 variables. Right, and you can't solve for either. Remember, if you want to solve for 2 variables at the same time, you actually need 2 equations. Okay, so don't do this. You can write it there on the side if you want to, just as a reminder, because now you have 2 variables. Which is not good. But if you sub in a y-intercept, you will always get rid of one of those. I will show you in the next example what happens if it doesn't get rid of it. You need to take all. Okay, so now we can rewrite here y is 3 b to the x minus 1. Alright, we calculated that our a value is 3. So if we look at that equation, now instead of a, we can now replace it with the actual value of a. How many variables do we still have to solve for, guys? 1. We still just need to solve for b, which is perfect because we still have a point, right? We have the point 1, 5, which I'm now going to sub into this equation. 1, 5. So I'm just going to put this on the left-hand side because I know I'm going to solve for b. So we're going to get 3b to the power of x, which is now 1 for this point. So 3b to the 1 minus 1 is equal to 5. How many variables do I have there? 1, right? Just b. And I can solve for b here quite easily. The negative 1 must move to the other side. It's going to become plus 1. So we're going to have 3b equal to 5 plus 1. Yes, good, which is 6. And now we must divide by 3. And 6 divided by 3 is just 3. There we have our answer. Now guys, for this example, you actually could have stopped there because they just asked you to solve for A, B, and C. But it is good if you just write your equation down because sometimes you're going to have to use it later on. Okay, so the equation was, now you must be careful guys, you can't just write 32 to the x because then it's going to look like 32 to the x. All right, what is this 3 and b? What are we actually doing with these? Multiplying, right? So you have to just put a dot there to show that those two are actually multiplying. Okay, if that dot is not there, it's going to look like 32, which it's not. Okay, so 3 and then a 2 to the x minus 1. Okay, this question will be worth more marks because it was more complicated. You have to start in 2 different points. And so like I said, you would get 1 mark for getting your value there. Then you'll get a mark for subbing in this point. You get a mark for calculating A. You will then get another mark for subbing in the second point and a mark for calculating B. And then if they ask for the actual equation, right, this is actually where the question stops. So this would be 5 marks. But if the question said find the equation, then that would be okay. But remember the question actually takes some of the values. Okay, any questions on that side? Right, let's look at number 2. And now this is the blue graph. So if you want to, you can just underline that or highlight it in the color that you put blue. Again, I'm just going to, on the side, write the standard form that we are used to working with. And again, we can see that what they've given us here is different from what we've been working with. Firstly, do you guys notice that they've actually given us A? Right? The A value is always the number that is in front. Okay, the B value that we are used to is the value that has the exponent. In this case, they've used B for B, right? Or instead of B. So this value here is our A value. So we're not going to have to worry about calculating A, which is quite nice. They've given us the A value. Now guys, this is different, right? So we see in our standard form, we have x minus p. In their standard form, they have x plus p. So it's not the end of the world. I'll show you now how to work with that. But instead of q, they have now used e. But again, guys, what does q represent? The constant term. This represents the asymptote, right? So our q is their e, but it represents the same thing. The constant term, the one that's just a number, the one that doesn't have an exponent of x, that is the asymptote. So let's look at our graph, guys. The asymptote is always the easiest one to see. What is the value of our asymptote? The blue asymptote is 2, right? Y equals 2 is the blue one. So E is going to be equal to 2. Again, I'm just going to write on the side here, this was the horizontal asymptote. 1 mark for that. Okay, so guys, if you really don't know what's going on, you can at least write that. Okay, the one that's just a number is an E. It doesn't have an X attached to it, that will always. Okay, now let's quickly write this down. Y is negative 2d to the x plus p plus 2. And I'm just rewriting that equation that they gave us. Guys, unfortunately, we need to work with the equation that they've given. Okay, you can't say, oh, I don't like what's happening here. I'm going to write our version down. So you have to work with what they've given you. So I am just replacing E with 2. Now let's look back up. We said we're going to start with the y-intercept first, right? Did they give us the y-intercept of this graph? Yes, 0, -8, right? The point on the y-axis. That is 0, -8. Let's see what happens when we do that now. 0, -8. I'm going to put this side on the left because whatever I'm going to have to solve for is here. So we have -2d to the power of x plus p. What is the x value of this point? 0. Okay, so now it's going to be 0 plus p. So that doesn't work as well as the previous one. Then we have a plus 2, and that is equal to y. What is the y value of this point? -8. Is the same thing going to happen here now? Is d to the power of 0 plus p also 1? No. Okay, if it was d to the 0 would be 1, that would be perfect. But unfortunately, it's 0 plus p. So what you can do is you can simplify that to d to the power of p. But unfortunately, it's not going to be equal to 1. Can I maybe just simplify this equation a little bit? Okay, I can make d to the p sub. Let's move that plus 2 over. What must I do with it then? -2. Okay, so I'm going to have -2d to the p equal to -8 minus 2 is -10. And what can I then do with that -2? Yeah, I have to divide on the other side, right? So -10 divided by -2 is going to be +5. Yeah, I haven't solved for d or p, unfortunately, right? But what I was able to do was I was able to just get a more simple equation. Right, we'll see what we can do with that now. Guys, in order to solve for two variables, what do you need? Two variables, two equations. Okay, so I'm going to write a note here. In order to solve for so that I can put the other ones that they gave us on the blue graph was x-intercept, right? -1. Again, they didn't give us the coordinates of this point, so we know what the coordinates will be, -1 and 0, right? So that is now the second point that we're going to have to sub in. So we have to sub in -1 and 0. And again, we're going to sub it into this equation. So this is the equation as we have it at the moment, right? With our a value called in and our e value. So we need to make x equal to -1 there and y equal to 0. Okay, so we're going to do -2 d to the x plus p is now going to become -1 plus p plus 2 equal to 0. Okay, again, if my d and I'm getting a d to the third here. No. Alright, so we're going to do the same thing that we did up there, guys. We're just going to simplify it. So let's move the +2 and then that -2. So we're going to have -2 d to the -1 plus p equal to, I'm moving that +2. On the other side, it's going to be -2. What did I do with this -2 here? On the left, I'm multiplying by it. So when I move it, I have to divide by it. So I'm going to say d to the -1 plus p is equal to -2 divided by -2, which is 1. Now, actually, guys, we can actually solve this equation. You see this is an exponential equation, right? So can we make our bases the same? 1 is the only number that will actually work with this because anything to the power of 0 is 1. Even e to the power of 0. Alright, so I can rewrite 1 here as e to the power of 0. You can't do it with any other number, right? Just with 1. 1 is the only number that anything to the power of 0 will give you that. Yes, good. So what do we see here? We have our base is the same. So that means that our exponents will have to be the same. So therefore, -1 plus p is going to be equal to 0. That's lucky that that works out like that. We don't actually need to do simultaneous equations now. Okay, because when we subbed in the x into this, it actually gave us an equation that we can solve. Are you guys okay with what's happening here? Let's just make a note here. Exponential equation, therefore make bases the same. Some okay, so p, what does that mean with -1? If I move it, +1, hey. So p is going to be 1. Done. Have I solved for all of my variables? Do I know what d is yet? I will still get d, hey? But now guys, notice that we have that p is here and there. So now I can use my value of p to solve for d over here. Okay, so it's kind of like simultaneous equation. You have this one variable, you can take that value into other equations, solve the other things. So maybe you just make a star there and a star there, so that you know exactly what's happening here. We're going to say, therefore, d to the power of 5 d to 1 is going to equal 5. And guys, isn't that just d? Right? So 5. Okay, so we are actually done with this question because we P and we found D and we found D. Actually, we can leave it like that. That is D. But let's just write quickly. I know they ask for it. Sometimes they will. The equation, the last or the equation, I'm just going to move up. It looks like that. 1 equals -3 x plus 2 plus 2. All right, so now what do we get to 5? So this is going to become -2 times 5 to the x. What was our p value? 1. So that must now be x plus 1, guys, because it's saying x plus whatever p is. Okay, so if p is 1, we have to say x plus 1. Right. Actually, I'm going to write it here on the side so that you can see them both next to each other. -2 times 5 to the x plus 1 plus 2. That is the equation. All right. P was 5 and p was 1. What if p was -1? What would we have written here in this equation? Would have been x minus 1. Okay. All right. That was quite hectic, but we covered a lot of, yeah, this was a bit more complicated. Unfortunately, with exponential equations, because we're working with graphs, because we're working with exponential equations, it is often a bit more complicated than the other two. Okay, you might have to, yeah, touch on some algebra stuff there. I'm just going to give you 2 of these to do on your own. So it's exercise 12. I have very much run out of space. I'm just writing it here and I'll highlight it. Exercise 12 on page 105. Number 2. So as it's the one that we just did, you'll actually see that the first number 2, sorry, 23. We did number two, but they've given two sides, so one is very one people on and you have to take them back. And you can look at the exercise. I could board you on. And guys, then you're gonna do it right. Just from the people asking for one question, reflection, points of the section, and this one. Okay, and we'll copy that down. Can I put it up? You guys read that? Back of board. Yes. Okay, let's see. So let's see. Guys, if you're just looking at the graph, that's two examples. Exponential here, right? And then you guys see this how it looks. So h is an exponential, and now is a hyperbola. We're saying, and you can also see in the equation there's different attributes. So we're saying h is j is plus t. And then how is in the hyperbola over x minus w plus z. And we're going to find those out. So it's one exponential, one hyperbola.